Dear students, welcome to today's class. So in the last class I have explained the inverse trigonometric functions introduction and some properties of inverse trigonometric functions. Today we are going to see some more properties and very few related problems. Okay na? So let us start our class. See here properties we are going to see here. Sin inverse of sin theta is equal to theta. So these two properties side by side I am writing. So in your notebook also you learn this type only. Okay. So that you cannot get any confusion. Here you see here sin inverse of sin theta is equal to theta. Here sin of sin inverse of x is equal to x. Okay. Both here the output is only theta only. Here also x will come. But here theta belongs to closed bracket minus pi by 2 to plus pi by 2. Why? Because in this theta only sin theta is bijective. So in the last class I have explained clearly about that. Okay, right. So sin of sin inverse of x means what? Here x belongs to minus 1 to 1. See here sin of this is a theta. This is theta. Sin theta is equal to x means what? What is the range of sin theta? If it's so sin inverse of x is an angle. Therefore, sin theta means whatever. So this theta, the output is x here coming means what? X belongs to closed bracket minus 1 to 1. That is the maximum value 1, minimum value minus 1. Okay now. So here also cos inverse of cos theta is equal to theta. So here theta belongs to 0 to pi. Okay. Why? Y is equal to cos theta function is bijection. That means both 1 1 and on 2 in the interval 0 to pi only. Then only its inverse exists. Okay, right. So here cos inverse of x is equal to x. Why? Because what is the range of cos theta? Minus 1 to 1. That's why x belongs to minus 1 to 1. That is the minimum value is minus 1, maximum value is 1. See here tan inverse of tan theta is equal to theta. Theta belongs to open bracket minus pi by 2 to plus pi by 2. Okay now? Why? Because so y is equal tan theta is bijective. That means both 1 and 1 and on 2 in this interval minus pi by 2 to plus pi by 2. Whereas tan of tan inverse of x is equal to x for all x belongs to real numbers. Why? Because the range of tan theta is set of real numbers. Okay. So these two formulas you have to write down side by side. Now at this situation I am giving a small problem. Okay, let us try to do that. So what is sin inverse of sin 1? Here I am not mentioning anything here. 1 means what? Here 1 is radian. See here theta is measured in radians. Always if any unit of angle is not mentioned, if any unit of angle is not mentioned, then we have to treat that angle as a radian measure. Here sin inverse of sin 1 is equal to, I am writing 1, whereas sin inverse of sin 2 I am not equal to 2. Why? Because, tell me why it is not equal to 2. It is sin inverse of sin 1 is equal to 1, but it is sin inverse of sin 2 is not equal to 2. Why? Just to think of a little why. So the answer is this. The answer is this. 1 radian means here, 1 radian means approximately 57 degrees 16 minutes. So here theta, so whatever may be here, theta should belongs to minus pi by 2 to plus pi by 2 means what? Minus 90 degrees to plus 90 degrees. The angle should belongs to minus 90 degrees to plus 90 degrees. Then only sin inverse of sin theta will come theta. Here 1 radian means how much? 57 degrees. That's why that lies between minus 90 to plus 90. Of course, closed bracket. Therefore, here as it is 1 will come. But whereas 2 radians means how much? 2 radians means 2 times 57 degrees. That means 114 degrees. 114 degrees, it crosses the 90 degrees. it crosses the 90 degrees, then it is not equal to 2. But what about that value? What about that value? How can you say that? How can you find out this? Sin inverse of sin. Sin inverse of sin 2 value is equal to how much? Understand? How to find it? So, definitely some value will be there. Sure, that some value will be there. What is that value? That we have to find out. So, don't skip this video. In this between the video, somewhere I will explain what is the value of sin inverse of sin 2. Okay, don't skip this video. Okay, now coming to our properties. Our properties, tan inverse of x is equal to x belongs to real numbers. Okay, I will explain this. Definitely I will explain in this video. Don't skip the video. Okay, now right. So let us see some more properties. Let us see some more properties of this inverse trigonometric functions. So in the general trigonometric functions, we have seen the trigonometric ratios of negative angles, that is equal to sine of minus theta is equal to minus sin theta, cos of minus theta is equal to cos theta, tan of minus theta is equal to minus tan theta. There I explained the proof of those properties also. Sine of minus theta is equal to minus sin theta, cos of minus theta is equal to cos theta, tan of minus theta is equal to minus tan theta. I have given the proofs also. But we are going to see here the inverse properties of inverse trigonometric functions for negative angles. So here negative values, sorry. So here x belongs to minus 1 to 1 here. Now sin inverse of minus x is equal to minus sin inverse of x for all x belongs to minus 1 to 1. So cos inverse of minus x is equal to pi minus cos inverse of x. So here observe here it is not it is here pi minus cos inverse of x. So again you will get here pi minus secant inverse of x, pi minus cot inverse of x. Just for only sin inverse of minus x, tan inverse of minus x, cosecant inverse of minus x only, minus minus minus, for all minus will come, but this cos inverse of minus x and the secant inverse of minus x and the cot inverse of minus x, that only for pi minus cot inverse of x you will get. So here these results are, as already you know that these conditions you are already know. So why? Because the domain of inverse sine function is equal to minus 1 to 1. Here also domain minus 1 to 1. For inverse tan function, domain is set of real numbers. Okay, right. So cosecant inverse of minus x is equal to minus cosecant inverse of x. Secant inverse of minus x is equal to pi minus secant inverse of x. Cot inverse of minus x is equal to pi minus cot inverse of x. For all these things, proofs are there. For all these things, proofs are also there. Okay, na? So try to learn those proofs also one by one. But for a JEE mains point of view, we will make use of the results, not the proofs. Okay, so all of you try to understand these proof results. Okay, so let us see some more results, some more properties of this inverse trigonometric functions. So actually they are very important. We use these three properties very occasionally. The first property is sin inverse of x plus cos inverse of x is equal to pi upon 2 for all x belongs to minus 1 to 1. Why? Because for sin inverse of x and cos inverse of x, the domain is minus 1 to 1 only, as already I given a table also. For tan inverse of x plus cot inverse of x is equal to pi by 2 for all x belongs to R. Why? Because for tan inverse of x, cot inverse of x, domain is set of real numbers only. Okay. So secant inverse of x plus cosecant inverse of x is equal to pi by 2 for all x belongs to, except this interval, except that interval, that is minus infinity to 2 minus 1 union 1 to plus infinity. Okay, na? So these three properties are we will use occasionally we use of that. So sometimes while solving the problem, so if it is sin inverse of x is there, in this place pi by 2 minus cos inverse of x, like that also we can use. So we can take this plus cot inverse of x to right hand side, otherwise secant inverse of x to right hand side, like that also we will do. Okay, na? So I hope that you understand these three results also. Let us see some more results. Welcome to this property. So here if you see that everything is somewhat tension like this it will be create. So the thing is here, generally students will make use of this result. Tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y upon 1 minus xy. You can easily prove this by, because if you know the formula of tan of a plus b, so this is equal to tan a plus tan b upon 1 minus tan a into tan b. Okay, making use of that formula we can prove this result, tan inverse of x plus tan inverse of y is equal to, generally immediately if the formula is given, generally students they will write that tan inverse of x plus y by upon 1 minus xy. But the thing, remember that here x and y should be less than 1. When x and y should be less than 1, then only you have to make use of that formula. So if it is x and y is greater than 0, x greater than 0, y greater than 0 and x into y is greater than 1, then your formula will be pi plus tan inverse of x plus y upon 1 minus xy. That's why. So before applying this formula, tan inverse of x plus tan inverse of y, confirm first of all thing x into y. X into y less than 1, x into y greater than 1. First you confirm it. Okay now. First suppose if it is given that tan inverse of minus 1 plus tan inverse of 1 by 2. Tan inverse of 1 and if it is a 1 means 1 degree. So tan inverse of 1 into tan inverse of 2. If it is given like this, tan inverse of 1 plus tan inverse of 2 if it is given. So here 1 means x means 1, y means 2. Here x is greater than 1, x is greater than 0, y is also greater than 0. That's why then, and also moreover x into y is greater than 1. 1 into 2, 2 is greater than 1. Then you have to apply this formula, that is pi plus tan inverse of 1 plus 2 upon 1 minus 1 into 2. Understand this? So here x should be positive, y should be positive, x into y greater than 0. That means x into y, 1 into 2 is greater than 0. Then you have to apply pi plus tan inverse of 1 plus 2 by 1 minus 1 into 2. That formula you have to apply. Understand this? Okay, right. So now same here also, if it is both are negative, x less than 0, y less than 0, but xy is greater than 1, then it is minus pi plus tan inverse of x plus y by 1 minus x1. So be careful about these formulae. Okay, that's why you write all these formulas in a separate notebook and repeatedly you revise these formulae. Okay, so the next one is tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y upon 1 plus xy. This formula is valid when x into y is greater than minus 1 only. And the next formula, here x greater than 0, y less than 0 and xy is less than minus 1, then tan inverse of x minus tan inverse of y is equal to pi plus tan inverse of x minus y upon 1 plus x plus y. The next also, this happens when it is xy less than 1. Here also xy less than 1, but here x greater than 0, y less than 0. Here x less than 0, y greater than 0. Opposite signs. Okay, then minus pi plus tan inverse of x minus y by 1 plus. Generally, but in our examinations or competitive examination, just majority of the problems will be based on the first formula only. Majority of the problem. Occasionally you will get these two formulas. Occasionally you will get this formula, but be in competitive examination point of view, be alert while applying this formula. Okay now, right. I hope that you understand these properties. Let us see some more properties. So here sin inverse of, they are very, very useful while solving the problems. So here the properties, sin inverse of x is equal to cos inverse of 1 minus x square, tan inverse of x by root of 1 minus x square. These problems can be properties can be proved using proper substitution. So here if we put x is equal to sin theta, so here x is equal to sin theta, then this implies cos theta is equal to how much? Root of 1 minus x square. You know that how to do that. Why? Because sin square theta plus cos square theta is equal to 1. Therefore, cos square theta is equal to root of 1 minus sin square theta. Cos theta is equal to root of 1 minus x square. There you got root of 1 minus x square. Okay, na? So, therefore, this theta is equal to put x is equal to sin theta. That means sin inverse of sin theta is equal to how much? Already we know that theta. This theta is equal to how much? This theta is equal to, can I write it as cos inverse of root of 1 minus x square? Here theta is equal to cos inverse of root of 1 minus x square. Can we write? Yes, we can easily write. So, there also we know that. So, sin 2 theta in terms of tan theta. Sin 2 theta in terms of tan theta is equal to how much? So, this is equal to tan theta is equal to, we can write it easily. So, this is tan theta is equal to sin theta by cos theta. So, here sin theta means sin theta by cos theta, that means x by root of 1 minus x square. Okay, na? So, that is a easy one. So, next one is cos inverse of x is same as sin inverse of under square root of 1 minus x square. Therefore, tan inverse of x is also tan inverse of x is equal to sin by cos. The sin value by cos value. Okay, na? Right. Next, tan inverse of x is equal to sin inverse of x by root of 1 plus x square. Cos inverse of 1 by root of 1 plus x square. Okay, na? So, we can easily solve this type of properties. All these properties by taking x is equal to sin theta, here x is equal to tan theta, we can solve these problems. Okay, na? I hope that you understand these properties. So, based on some property, so I am going to explain. In the starting itself only I have given one problem. Now I am going to explain that problem. Okay, then let us start the problem. In the beginning itself I have given one problem formula. What is that? Is so sin inverse of sin theta is equal to theta, where theta belongs to closed bracket minus pi by 2 to plus pi by 2. Closed bracket minus pi by 2 to plus pi by 2. Okay, now. So, basing on that I have given one problem. What is that problem? So, that is equal to sin inverse of sin 1 degree is equal to 1 I am saying. So, whereas sin inverse of 1 not 1 radians and 2 radians I am not saying, it is 2. Okay, now, right. Why I am not it is not equal to 2? So, why? Because see here, 1 radian means 57 degrees. Of course, it is approximate value. 2 radians, 2 means already I have given that if any unit of angle is not mentioned, that value will be treated as a radian measure. Okay, now. So, 2 radians means how much? This is 114 degrees approximately. Therefore, it crosses pi by 2. Okay, now. But if you observe here, if you observe pi by 2, we have to make it into less than pi by 2, less than pi by 2 or more than minus pi by 2. How to do this? Shall we subtract from 180 degrees? See here, pi minus 2 radians, or this pi minus 2 radians will belongs to minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. Why? Pi radians means how much? 180 degrees minus 2 radians means, so this is equal to 180 degrees minus 2 radians means 114 degrees. So, this is approximately, it is a 6, here 7 minus 1, 6, 66 degrees. So, this is nearly 60 degrees, which lies between minus pi by 2 to plus pi by 2. Now, let us see the value of sin pi minus 2, sin pi by sin 180 minus theta, sin theta, that is equal to sin 2 radians. Okay, na? Sin 180 minus theta, sin theta. Therefore, in place of 2, can I write down pi minus 2? Yes, I can write down. So, therefore, sin inverse of sin 2 is equal to sin inverse of sin, in place of 2, I am writing pi minus 2 radians. Pi minus 2. Now, then you have the right to apply this formula. You have the right to apply this formula. Why? Because here theta, which is lies in the minus pi by 2 plus pi by 2. Here also pi minus 2 radians, pi minus 2 radians, pi minus 2 radians is equal to 66 degrees. Therefore, its value is pi minus 2 radians. Understand? I hope that you understand this solution. Sin inverse of sin 2 is not equal to 2, but it is equal to pi minus 2. Understand this? Okay. Now, let us see some more this type of problems. Let us welcome to one type 1 problem. So, very easy problem this is. If you, even though it looks like just like a very big problem. So, if you solve this problem logically, the problem is a very easy one. So, here x, y, z are 3 variables and which lies between -1 to 1 such that sin inverse of x plus sin inverse of y plus sin inverse of z is equal to 3 pi by 2. Now, now we have to find out the value of x power 2022 plus y power 2023 plus z power 2024 minus 9 upon 2000 x power y power z power. Same. This value same. So, generally students they start off doing this type of arithmetic mean is greater than or equal to geometric mean like that. So, no need of do. So, first concentrate on this condition. Concentrate on this condition. Sin inverse of x plus sin inverse of y plus sin inverse of z is equal to how much? 3 pi by 2. That means the sum of these 3 angles is equal to how much? 3 pi by 2. That means 270 degrees. 270 degrees. Now, he is not mentioned the that is the volume of this each angle, but for my convenient, I will take sin inverse of x is equal to sin inverse of y is equal to sin inverse of z is equal to each equal to 90 degrees. Each equal to 90 degrees. Can I take 90 plus 90 plus 90? 270. Easily we can take. Now, if it is sin inverse of x is equal to 90, then x is equal to sin 90 degrees. Therefore, x is equal to 1. How much? X is equal to 1. Similarly, y is equal to 1. Similarly, z is equal to 1. Understand? Very easily. The only thing lies is considering a sin inverse of x plus sin inverse of y, sin inverse of z, each is equal to 90 degrees. So, if you think that the problem is over. Now, x value is 1, y value is 1, z value is 1. Substitute here, 1 power 2010 is 1, 1 power 1 minus 9 by, so this is 1 plus 1 plus 1. 3 minus 9 by 3, that is 3 minus 3, 0 is your answer. Okay, 0 is your answer. So, dear students, I hope that you enjoyed today's class and with some more concepts and some more problems, I will stand before you. Until then, all the best.